And welcome to the Evidence Reasons Academy. This is a nerd outreach session. Glory and honor to our Lord and Savior Jesus Christ. A senior evolutionary biologist has reached out to me and wants to argue and discuss. I think he's quite convinced that I'm mistaken, and I'm quite convinced that he's mistaken because I need to protect his anonymity. And I really, sir, if you're listening, I totally appreciate what you're undergoing, the amount of ridicule and marginalization and persecution you will be subject to if you are too friendly to the other side, if you entertain even questions, that you even have dialogue. I know what you're going to be under, and I want to set a standard of protecting people's anonymity, especially the higher up they are. So don't even worry that I'm going to even try to figure out who you are. It doesn't matter, because I'm not just speaking to you, but to every other evolutionary biologist that has similar questions or concerns and is trying to keep an open mind to what's going on, or at least maybe a critical eye, even if they sternly disagree. At some point, they're going to have to deal with some of these arguments because they're getting stronger, especially in light of the fact of some of the things I'm reading. Like yet last night, I read Kunin's article on the third way, and it basically declared that neo-Darwinism is defunct, and that was the thing that was being defended tooth and nail. It's pretty much fallen apart, and there's really not really much of a synthesis theory. Kunin put forward the next generation synthesis or whatever. So this conversation began because of a variety of things. My debate with Aaron Raw, which included this diagram here that I'm going to show, the protein orchard. And Grynch Linchpin is the evolutionary biologist's handle. I'll say it's his name, Grynch. You said this is no problem for evolution. I beg to differ. It's not an immediate problem from common descent. You can have common descent with independent protein origins, where the proteins from like somewhere in the genome just kind of emerge. There are severe problems with that, and I'm going to discuss why. Because I'm trying to protect your anonymity. I know we can't have a voice conversation. Your friends, your colleagues will recognize your voice, and I get that. So we're going to have to do this where I might respond in video, you're going to respond in text, and we're just going to go back and forth. This will be educational to creationists and ID proponents, creationists of both the old Earth and young Earth variety, or some variation thereof, and ID proponents. So I'm doing this because I think this is going to be valuable. Also, there are some things I'm trying to push through peer review. Some things fly that don't, that I didn't expect, and some things that I expected would fly didn't. That's just how it goes. The peer review process of being rejected sometimes does improve the manuscript. Sometimes it's just really insulting and doesn't reflect well on the peer reviewers or the industry in general. And I may cover that a little bit. And this is why I distrust not the peer review process in general, but the peer review process where there's no experimental verification of theory, and that is evolutionary biology. I had discussed on this channel my work on Maxwell's equations, trying to recapitulate the derivation of special relativity. Experiments were done with oil lamps, telescopes on slabs of stone that were put on Mercury, and Michelson and Morley were just spinning this little rotating, it's like a rotisserie sitting on Mercury with an oil lamp. They're looking at the light from an oil lamp. And the consequence of that is they realized special Lorentz, and then Einstein realized the time, or shall we say, in my opinion, more precisely, clocks will tick slower the faster you move. That's an incredible inference. The theoretical trail was something that I had to demonstrate to my professors in graduate school that I understood how the calculation is done. Let me show you what I consider. I had to do this thing that studied the twin paradox. I had to begin with Maxwell's equations and then this D'Alembert of the Maxwell's equations, electromagnetic wave equation. And then I had to do this derivation for my professor. And it's been a long time. It's been about 15 years since I've done it, and I'm a little rusty. But I had to go through it. And this time it took me 40 hours to do this derivation that only took me 4 hours earlier. That was when I was much younger. And this is 21 pages of showing how this was deduced. This is a draft, so there's some stuff that's clumsy, but the equations were just gigantic. And a single mistake and the derivation falls apart. So here I was doing this and just marveling that they could deduce from the study of light from an oil lamp that was on some sort of rotisserie that was sitting on a bath of mercury. They didn't have modern electronics. They didn't even use a light bulb because this was so far back far back only around the time the light bulb was invented by Edison, that they had to use oil lamps. But they were able to deduce using math like this and derivations akin to what I'm showing here. So this is not unique to me, but it was assigned to show how this is concluded. And at the end of it, I got that. This result was very important, and it showed that when you have a spaceship traveling at high speed, the clock will slow down. This is the famous twin paradox. If the girl is flying in a spacecraft and she has a twin brother, fraternal twin brother, she's flying at 99.999999996% the speed of light, a day for her will be like 1,000 years for her fraternal twin brother. This has been, although not confirmed to that extent where we have a day equal to 1,000 years, we certainly have evidence with our GPS clocks that have to be adjusted for this phenomenon so that we can have more precise and accurate position data in our GPS devices here on Earth. And there have been numerous other experiments in particle accelerators, the Heffel-Keating experiment with airplanes. This has been confirmed, the cesium beam atomic clocks, etc. This is what I call, what I've tried to say is this is like the gold standard of how science should be done, where you can start with an inference and you build all these wonderful insights, and you don't really modify the theory. Maxwell's equations, it's 99.9% good enough for everyday applications. Everyday meaning computers, satellites, radars, etc. Where the domain it doesn't apply is kind of at the femtoscale, at the atomic scale. We have to use quantum electrodynamics instead of classical electrodynamics, which is what I was showing here, was based on classical electrodynamics. But imagine that Einstein was able to study these equations and then derive special relativity from that. That's a solid claim of a theory. A theory that where people are fighting, like between Jerry Coyne and the third way, and all these people are having fights. They don't know what mechanism is in play. It's contested how good or adequate some explanation is. This is not an indication of a healthy theory in terms of physics and chemistry. And Um, what's happening in the present day, I'll argue, is the experimental results are very negative toward the claims of evolutionary theory. Not the claim of common descent, but the emergence of complexity. So let me try to, I touched a little bit on what Aaron Ra was saying. And so let's go to the definition of evolution. So this is from the Berkeley website on Evolution 101. It says, biological evolution, simply put, is descent with inherited modification. This definition encompasses everything from small-scale evolution, for example, changes in the frequency of different gene versions in a population from one generation to the next, to large-scale evolution, for example, the descent of different species from a shared common ancestor over many generations. Evolution helps us to understand the living world around us as well as its history. That looks like a good enough claim, defensible, and it's one that evolutionary biologists have worked from. I'm going to put my objection to this definition because there's a big piece that is missing, and it's related to this protein orchard problem. So we had a panel of people kind of giving their 2 cents what their objection was. And I looked at some of what all they said, and I kind of synthesized it and kind of came up with my own. And I said modification. So they used the word inherited modification here. Modification is inherited modifications are accepted by faith to be consistent with statistical expectation of physics, chemistry, and probability, but not proven nor rarely even explored. And when they are explored, they frequently appear inconsistent with expectation by large margin. That is the problem. Evolution helps us. No, and I disagree. Evolution does not help us understand the living world as well as its history. It pretends to. Evolution does not help us to understand the living world, much less its history. I mean, look at the whole thing with junk DNA. I can cite Francisco Ayala totally blowing it on ALU elements. How about Jerry Coyne on the backward retina? Supposedly backward wiring of the retina. I mean, this is just, what about now that we're discovering membraneless organelles that are expressed from the, that are created by ribonucleo complexes, RNA plus a protein. I think that's the right term. Ribonucleoprotein complexes, RB, something like that. We didn't expect that, we thought this was just all junk. We know now with phase separation we shouldn't be too quick. How has this helped? I have counterexamples. It says it helps us to understand. I say no, it helps us to misunderstand. It has misled us. That's not very helpful. You could just as well assume that a creator had put together the world to help us understand our own biology. Therefore, you have comparative anatomy, etc., and model organisms. You don't need evolution to do that. In fact, we have lots of convergences morphologically that help us understand. So what's the need of assuming that the patterns of similarity are due to common descent? So no, it doesn't help us to understand. It doesn't help us to I mean, if you can't understand the living world in the present, why should we expect that it explains the past? So, this is all going to be borne out. Some people have been fighting the junk DNA wars for a long time, like Dan Graer. He's becoming increasingly isolated. I know people that work on the issue of chromatin and some of these expressed RNAs and then phase separations. Kind of the working assumption is it's there for a reason. It's not junk. And so Graer's looking just increasingly marginalized. And it's just kind of ridiculous. He started saying ENCODE can't be right, and he kept upping the number of the percentage he thought is functional. It's just ridiculous. I mean, how far does he, this is not like when I showed you the equations of how one can derive special relativity from Maxwell's equations. You don't have all that sloppiness in just kind of revision because you got embarrassed. This is the strength of the theory. It has stood the test of time, and it has advanced technology. I can't say the same for evolutionary theory. So when I look at this definition, I could have, I could complain about, no, it doesn't help us understand the living world, much less history. It is not consistent with probability, chemistry, at least when it's explored. And I'm going to cover that with the protein orchard. And modification, nor inherited modification nor inherited modifications. Probability, I should say physics, chemistry, population dynamics, probability. Physics, chemistry. Hang on, I want you to so you could see what I'm saying. Modifications, nor inherited and accumulated modifications. Modifications, be they inherited, be they inherited and accumulated, are accepted by faith to be consistent with statistical expectations, physics, chemistry, probability, and population dynamics, but not proven or rarely explored, but not proven or rarely explored. But not nor rarely explored to be consistent. And when they are explored, they frequently appear inconsistent with expectation by a large margin, as if requiring a miracle. Evolution does not help us to understand the living world, much less history. Plenty. Okay, you may protest that it helps us understand history. I was reading stuff about eukaryotic evolution, and they said we'll never know. So I'm just like, no, it's an overinflated claim. and all the disputes about mechanism regarding modern synthesis. I mean, you can make up all these claims. I mean, it may or may not. But my main beef is modifications, be they inherited. Okay, so let's look specifically at the protein orchard. That is kind of the heart of this dispute here. Oh, let's look at the, one that I'm familiar with. Let's look at the topoisomerase. Some people will say, this is an interesting one because some people will say, well, we don't need a topoisomerase for the first life. Okay, so it has to evolve after the first life. It's not if you're going to invoke a genome without a topoisomerase, then you're going to have to invoke that it evolved after the first life. Now it is descent with modification. Let's look at the definition again. Evolution's descent with inherited modification. So are we going to say there's inherited modification? Does it have to be vertical? Or, does horizontal gene transfer count as inheriting it from another creature? This is what's kind of funny. But let's just say, let's just look at the topoisomerase, look at the probability. We can move to other proteins. The topoisomerase is a homodimer. That means the gene will express two identical copies of the polypeptide. The polypeptide will then, the two copies, like represented here by red and blue, will spontaneously join together. At least in vitro experiments have shown that this will spontaneously assemble. Now, this may look innocent enough, but what is the probability we'll have a geometry that has the proper shape such that the connections will happen? Does anyone try to bother to figure out how, the probability of having a geometry such as this to create a topoisomerase? This is like the probability of a lock and key. By way of metaphor. And Bruce Albert shows in Essential Cell Biology, this diagram from the 5th edition. If you have two complexes, in this case this is a heterocomplex, not a homocomplex, you have charge distributions where you have a positive charge on one and a negative charge on the other. They have complementary shapes so that they will connect. The topoisomerase has to connect It connects 64. I did a study using the PISA system. Let me see if I could describe the PISA system. The PISA system estimates okay, so yep. So I'm going to show this here. Thank you for your forbearance. This is the protein data bank PISA system. You take the X-ray crystallography data of, like, say, a topoisomerase, very difficult to do, and you pump it through the PISA system. It's going to estimate the positions and charges of in the homodimer. So let's again look at the homodimer here. So we have this topoisomerase. Let me see if I have a close-up of that homodimer. this isn't, there are actually 64 positions how this will connect. So that interface will happen. If the interface, I mean, if we have kind of, how can random mutation create something that's going to untangle the DNA through a process of first locating where the tangle is, cutting the DNA, then untangling it, and then what they call ligating it, reconnecting it in the context of a homodimer. This boggles the mind. Now, there's not only one way to do this, because bacteria uses a heterotetramer to do this. But you still have the same problem. This is like saying, the closest analogy I can come up with is in a car, there's ways to mix fuel and air. It used to be with carburetors, now with fuel injectors. You still need some machinery. So there's not just one way to build a machine like that, and like there's not one way to build a functional protein that does basically the same job. But the problem is the difficulty in making parts that interconnect adequately to do the job. I mean, intuitively, this is just absurd to say random mutation can achieve this. It's also absurd to say, or it's very premature to say, random mutation plus natural selection can do this. A lot of half-formed genes, they're toxic. Why should selection envision something that's going to make a topoisomerase? The topoisomerase has to cut. So let's say we have something that works just like a topoisomerase. It ends up being kind of like an endonuclease and just shreds the genome. That's not going to be, wherever it finds a tangle, it just cuts. But it doesn't untangle and religate. This is terrible. So does anyone actually try to do the calculations? I mean, how are you going to get 60 interface points? This has to be not just the fact that it's shaped right, but it has to be shaped right, the proper binding affinity, so it's not too tight or too loose. Just like a lot of parts, you don't want, if you're going to assemble and disassemble molecular machines, you don't want things binding too tightly, and you don't want them to bind too loosely, so that when they operate, I analyzed this particular protein. I mean, I could go into more detail if you really want to know. This is like only 1,500 amino acid residues, and when I looked at all the sections of all the domains and all the parts, they have to be geometrically positioned well. It boggles the mind to think random mutation could do this. If one's gonna invoke selection, the problem is it's like, well, what's the probability we're gonna have a selective force? Does anyone calculate that? Is it assumed to be 100% there's gonna be a selective force that's gonna assemble this? There's no evidence of that. Absolutely zero. In fact, experimental evidence to the contrary. And also theoretical stuff that was done in evolutionary algorithms, of which Avita is one. And Avita is the exception, where it kind of does not behave like other evolutionary algorithms. They had to make something kind of exceptional. And Avita is certainly not consistent with what we see in biological organisms. So I have a real problem with just saying, well, it's not just random mutations, natural selection. It's like, well, what actually happens in nature isn't, it doesn't parallel what what evolutionary biologists and the Avita proponents have imagined happens. And so there's a disconnect. And so my claim that the evolution of major protein families, such as the topoisomerase, is inconsistent with physics, chemistry, statistics, and population dynamics. And that's a testable prediction. It's going to get worse because multimeric proteins pose this problem. It needs very precise geometry, down to angstroms. of positioning. You have to have the right shape, the right charge distribution, so that these parts are floating all around the place, will connect in the right geometry. It could be that you have so many positive charges here and so many negative charges here, and it connects wrong. I mean, there has to be a lot of foresight to be able to build a multimeric complex. And I don't know that we have the computational capability to, even if we were trying to achieve this. I could go to other proteins like zinc finger, the insulin receptors, etc. I mean, and I put that in the debate. So when people say this is not a problem for evolutionary theory, it's like, why not? Do we just? It's not a problem if you disregard physics, chemistry, probability, and population dynamics. It's only not a problem in one's imagination. It's not. It's not even asked. That's what I find very bothersome. That no one is asking these questions. They're just assuming that just because it exists, the probability is 100%. That's actually very faulty reasoning. It's very faulty reasoning. Okay, so let's say that there's no divine. I mean, even if one believes in God, one can say, well, God didn't have to intervene. Well, the problem is, just because something exists doesn't mean the a priori probability is 100%. So, for example, if we see 500 fair coins and they're all arranged, they're all showing heads, it's 100% probability that it's showing heads. That's not the point. The a priori expectation is that is several standard deviations from expectation, enough that one would think that random chance is not an explanation. So some people say, well, there are other mechanisms. It's like, okay, random chance plus whatever. Define it, provide experiments. And it is a problem for evolution until they have credible experiments that will show that these probabilities can be overcome. Because the higher probability case is that these things degrade, they accumulate. At best, they don't improve, they don't create substantially new big protein families that are deeply integrated, particularly the multimeric. I mean, I'm sure that there's some exception here, but how many, if the rule is loss versus construction over time, then this is a problem for evolution. So I'm not going to make a categorical statement, as some of my colleagues, that it's absolutely impossible. I'm just going to say it's not looking good. It doesn't bear the characteristics of a healthy discipline, where opinions count more than experiment and rigorous theory built up from first principles physics, chemistry, statistics, and population dynamics. I'm sorry to be harsh, but when I look what's happening with the demise of modern synthesis and the attempts at replacements, and no one's agreeing, this is not the state of a healthy paradigm or claim. So I mean, I certainly have my personal ideas for alternatives, but to be cautious and circumspect, I would just say, okay, maybe we don't know is better than claiming it's not a problem. So that's what I have to say, Grynch Linchpin. Thank you for taking time to listen to this, and I know this has been 37 minutes of me talking, but maybe in the dialogue you can ask me to be more specific, and so this is my opening communication, because this is very difficult to communicate the way we are, and I recognize your situation. So I hope you'll try to understand. I'm trying to meet you halfway. This is difficult for both of us, and I'm going to try to protect your anonymity. So best wishes. Thank you for your interest in my obscure little channel, and my obscure little ideas. So take care. Regards.